In the Anti-Atlas Mountains of Morocco, local communities suffer from drought and a severe lack of safe drinking water. Every day, women and children are forced to travel long distances across rocky slopes to collect just a few liters of water, an exhausting journey that weighs heavily on them and affects their daily lives. However, in 2016, a team of German engineers arrived with a remarkable idea, building giant mesh structures, each over 6 meters tall, designed to capture the morning fog. Tiny droplets of fog condense on these nets and slowly gather, eventually turning into streams of fresh, drinkable water. At first, this invention seemed almost like science fiction, but today, it is saving the lives of hundreds of people in these villages. In this video, we will take you step by step from the Atlas Mountains to the village household tap, to uncover the secret behind turning air into water, and how a simple network like this can transform fog into real life. This is what we'll explore in today's video. Alright, before we dive into the rest of this, if you're new here, consider subscribing. And if you like what you're seeing, hit that like button. It seriously helps the channel a ton. In southwestern Morocco, specifically in the Antilles Mountains on Mount Boutmesguida near the coastal city of Sidi Ifni, lies a land that seems as if time has forgotten it. Harsh, rocky mountains are battered by hot winds under a sky that rarely brings rain, leaving behind hundreds of days of severe drought. Groundwater levels decline year after year, while the remaining wells are salty, heavy with minerals, and unfit for drinking. In this unforgiving environment, about 60% of the population lives without running water in their homes. Every morning before the villages are fully awake, a daily journey filled with danger begins. Women and children make their way across treacherous, rocky slopes to carry a few bottles of water from a distant valley. Here, water is not merely a necessity, but a heavy burden that weighs on daily life, affecting education, health, and agriculture, and reshaping life entirely. Or still, fog drifting in from the Atlantic Ocean visits these mountains every dawn, wrapping them in a dense white veil before disappearing hours later without benefiting anyone. Yet this scene did not escape the attention of the German Water Foundation, which saw in the fog an unexpected opportunity. The foundation partnered with local engineers to launch a project that initially seemed like a bold dream. Harvesting water from fog, later named Cloudfisher, it is an innovative system capable of capturing moisture from the air, condensing it, and turning it into pure, drinkable water. This innovation, born in Munich through collaboration between the foundation and industrial designer Peter Trautwein, transforms what was once fleeting fog into a real water source for communities that had been living in constant thirst. It all began with a journey. The German scientists did not rely solely on theories or aerial images. Instead, they carried their equipment and traveled directly to Morocco, into the heart of the Antilles Mountains, to observe firsthand what happens on these mountains every morning. There, they noticed something crucial. Areas close to the Atlantic Ocean and the mountainous highlands experience dense fog at every dawn, fog that can be seen flowing between rocks and trees. Yet no one had ever thought of turning it into water. During their field surveys, they found undeniable living evidence: algae growing abundantly on rocks and tree roots despite the harsh drought. Such growth only appears when atmospheric humidity is high enough to sustain it. When they analyzed the fog, the discovery became even clearer. The air in this region carries a large amount of water vapor, quantities that can be captured and converted into clean, drinkable water. Based on this finding, true collaboration began between the German team and the local communities. They carefully selected a suitable site for the project and then launched the first real-world experiment. For a full 18 months, the engineers tested different types of mesh, lightweight fabrics, denser ones, and others with unconventional designs. But only one proved superior: a three-dimensional mesh capable of capturing the maximum possible amount of fog droplets. These meshes were installed on massive steel structures, forming something like a wall standing against the wind. This is how the Cloudfisher was born, a giant mesh wall positioned at the edge of the mountain, waiting for fog drifting in from the Atlantic Ocean to collide with it and turn into real water. After completing a precise survey of the terrain and wind directions, the real work began. The German engineers did not come alone, for the strength they needed lay in the hands of the local residents. Workers accustomed to the hardness of the soil and the harshness of the climate. They were the first to take up the digging tools, carving deep holes into the rock reaching a depth of up to a full meter. to serve as the anchor points that would support the steel columns. On the rugged, rocky slope, the hardest phase began. Heavy steel components carried on shoulders, dragged step by step toward the installation site. Each piece was secured with precision, because even the smallest mistake could mean the collapse of the wall in the first storm. Once the mainframe was raised, it was firmly anchored into the solid rock. The intention was clear: to build a wall capable of standing up to powerful winds, no matter how strong they became. Then came the most dangerous part: working at height. Wearing safety harnesses, the workers climbed long ladders and suspended their bodies in the air above the slope. There, at that elevation, they stretched each three-dimensional mesh panel, attached it to the frame, and adjusted every strand with care until vast networks stood before them, ready to capture the fog. At the heart of this system is a double-layered, three-dimensional mesh made of ultra-durable polyethylene, a material resistant to sunlight, abrasion, and the sharp temperature differences between the cold of night and the heat of day. Two parallel layers and millions of tiny openings trap fog droplets as they pass through, but capturing fog alone is not enough. Every droplet needs a path to collect it. Here, technicians began installing channels, tightening every hook and every bolt carefully to ensure that any droplet condensing on the mesh would slide directly into the pipe without being wasted. They then inspected every connection once again, because losing a single drop means a precious loss in a region plagued by thirst. Once the water gathers inside the channels, it flows directly into the collection pipe's final journey before it becomes ready for drinking. Each Cloudfisher unit was designed as a self-contained modular structure, requiring no heavy machinery, no engines, no electricity, and not even generators, only the wind that carries the fog, the mesh that captures it, and gravity that draws the droplets downward. Thus, a system capable of collecting water from the air was born. What makes the Cloudfisher system revolutionary is not its complexity, but its simplicity. It is one of the most sustainable water harvesting technologies in the world, designed specifically for places where drilling wells or building dams is impossible. From a distance, these giant meshes look like white sails spread high atop the mountains, standing silently against the winds coming from the Atlantic and capturing water from the air. The principle itself is simple, yet refined to near perfection. As fog passes through the panels of the three-dimensional mesh, tiny moisture droplets collide with the cool fibers and begin their journey. At first, they appear as small, shimmering points. Then they merge and grow into droplets that slowly slide downward under the force of gravity, falling directly into a pipe fixed beneath the frame. From there, fog turns into real water flowing through tightly sealed plastic pipes, heading toward storage tanks located hundreds of meters and, sometimes kilometers away from the site. In this way, an elegant cycle takes shape: fog, water, life. On average, just 10 Cloudfisher panels can produce between 600 and 1,000 liters of water per day, an amount sufficient to supply an entire village with all its needs. Even at the peak of summer, when temperatures exceed 40 degrees and the sky is completely clear, the system continues to capture water drop by drop. The impact of this transformation has been enormous. Local residents who once spent 3 to 4 hours of their day collecting only 20 or 25 liters of water can now simply turn on a tap and obtain water for cooking, washing, bathing, and even irrigating plants, something no one would have dared to imagine in this rugged region. However, the water provided by the system is not entirely free. The German team turned it into a sustainable business model. People pay according to their consumption, just like a regular water bill, with prices ranging between $1.2 and $1.5 per cubic meter. This system prevents waste and encourages responsible use of this precious resource. The Cloudfisher project has changed the lives of thousands of people. From 2016 until the end of 2018, the world's largest fog harvesting facility was completed in Morocco on Mount Boutmezguida, with the area of three-dimensional mesh expanded to nearly 1,700 square meters, making it a global model for utilizing fog. Today, this facility provides clean water to several villages in the region, helping meet the needs of residents and livestock with limited support for local agriculture. The system consists of multiple units connected through a network of pipes and storage tanks, where each square meter of mesh can produce about 22 liters of water annually, while total production can reach tens of thousands of liters per day during ideal fog conditions. These figures depend on daily climatic conditions and may vary according to fog density and humidity levels, making the system a true example of sustainability. The most remarkable part is this: no energy, no machinery, almost no maintenance, just a single investment that continues to operate for years without leaving any negative impact on the environment. Thus, from the heart of the Antilles Mountains, the Cloudfisher project succeeded in transforming fleeting morning fog into a real source of life. This innovation has proven that simple solutions, based on understanding the environment and harnessing its hidden resources, can make a tremendous difference not only in improving human lives, but also in protecting the environment and sustaining resources. From small meshes on mountain peaks to water tanks supplying villages, schools, and livestock, fog has become more than just a beautiful morning scene. It has become new life flowing into people's daily existence. And now, I have a question for you. Do you think ideas like the Cloudfisher project can help solve the global water crisis? Share your opinion in the comments. That's all for this video. Thank you for watching, and I'll see you in the next one.